Okay, so I'm Marissa Lake. I'm a freshman and a biology major.
I'm Melissa Duzos. I'm a nursing major and I'm also a freshman.
And today we're going to be showing you how to make polyvinyl alcohol slime.
So for materials, we need a PVA solution, a borate solution, a disposable cup, wooden sticks, and food coloring.
You also need goggles, 4% PVA solution, 4% sodium borate solution, and a waste beaker.
And gloves. So first, we need to pour out 50 milliliters of the PVA solution into the 50 milliliter graduated cylinder, which we have here, and pour this into the disposable cup. Then add a few drops of food coloring.
And then you also have to pour 5 milliliters of the 4% sodium borate solution into the 10 milliliter graduated cylinder. And then you also slowly pour that into the mixture in the disposable cup. And then what you get after you mix it for a while is this.
So for our theory, we found at Royal Chemical Society that when the borax and the borate solution combine, they form negatively charged ions. Those ions then create weak bonds with the hydroxide group from the PVA solution, which creates linked chains, and then those chains are what we know as cross-linking.
And actually when the linking, this is the PVA and then this is the borate ion, and when they link, these are the chains, water actually gets trapped in between the bonds, and this causes the slime to have a high viscosity, so it's like thicker and stickier. And it also is considered a liquid because you could shape it, but it always has the same volume. And the results are that it's very stretchy, so if you stretch it slowly, it stays together, but if you stretch it fast, it pulls apart into two segments.
And so the PVA and the borate create the slime, and the slime undergoes a chemical reaction because there is a new change of state and new viscosity. And it's a totally new different substance. So for our real-world applications, we found at Royal Chemical Society that slime is known as a dilatant, and dilatants expand when put under stress. So for an environmental application, something known as quicksand, which is also a dilatant. And so if we were to put a stick in the slime would expand and then contract around the stick so it'd stay put. And the same thing would happen if you were to put a foot in quicksand.
And another real-world application is actually a reporter from KPCC named Sandon Totten actually reported that in California they use a slime substance as a fire retardant to help prevent trees from burning down in forest fires. And their slime substance actually has ammonium phosphate in it. So what happens is the slime is dropped down from the airplanes and it sticks onto the trees because it has a high viscosity. And then when the fire from the forest fire gets close to the slime on the trees, it creates a chemical reaction, and then on the outside of the tree it's pure carbon. And pure carbon doesn't burn, so it's essentially protecting the tree from being burnt down. So from slime being a fire retardant to like kind of being in the environment as quicksand into what we know is like play, fun slime. Slime has many applications and is fun to make.